In this lesson, we are going to give names to topics we've already been discussing and also teach vocabulary words through the game of roulette. Our first vocabulary word is sample space. We've already been using this word through this unit. The definition, a sample space is the set of all possible outcomes, or in other words, a list of everything that is possible. Some examples. What is the sample space of flipping a coin? What is a possible outcome? We can either get a head or we can get a tail. What is the sample space of rolling a die? A single standard die has 6 sides, so the sample space would be 1, 2, 3, 4, 5, 6. What is the sample space of rolling 2 dice? We have also seen this diagram already. When we have 2 unique 6-sided die, this would be the entire sample space. There are 36 possible outcomes within our sample space, but the actual sample space itself would include getting a 1 and a 1, or a 1 and a 2, a 1 and a 3, etc. What is the sample space of drawing a card from a deck? The entire sample space for a standard deck of cards would be the ace of diamond, ace of heart, ace of club, ace of spade, 2 of diamond, etc., all the way until the last card, which is the king of spade. Explain the difference between the terms sample space and the sample size, or the size of a sample space. To answer this question, sample space includes a list of all the possible outcomes, whereas a sample size is how many possible outcomes we have. Our next vocabulary word is categories. Sample spaces can be broken up into categories. These are called subsets of the sample space. Name 3 categories of rolling a die. We know the sample space of rolling a die would be the numbers 1, 2, 3, 4, 5, 6. A category would be a subset of this sample space. So under the umbrella of these numbers, we could have a category that would include even numbers. Even numbers would be a subset because it includes the numbers 2, 4, and 6 from my entire sample space. Another example of a subset or category would be odds, the numbers 1, 3, 5. We also could have another category, numbers that are less than 4. Those numbers include 1, 2, 3, etc. Name 3 categories of rolling 2 dice. Picture the sample space of rolling 2 dice, a 1 and a 1, a 2 and a 1, a 1 and a 2, 3, 1, 1, 3, 4, 4, 6, 6. Some categories or subsets of the sample space would be pairs, getting a 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Even sums, so 2 and a 6, a 6 and a 6, etc. Sums that are less than 7, 1, 1, 2, 1, 1, 3. Name 3 categories of drawing cards from a deck. These are some that we are more familiar with. From a standard deck of 52 cards, we know that there are different types of suits, so we could have a category of hearts, or clubs, or diamonds, or spades. We also have 2 different colors of cards. They are red cards and black cards are 2 categories. We also have face cards, we have number cards, etc. Are there categories in roulette? So roulette is a game that we are going to be discussing to help us remember some of these vocabulary terms that we're introduced to today. This is what a roulette board looks like. There are numbers 1 through 36 on the board, and the colors are either red or black. We also have 2 numbers up here, 0 and 00, that are neither red nor black. We have first dozen, which would include these 12 numbers. Second dozen includes these 12 numbers. Third dozen. So when we're discussing dozens, again, it's 1 through 12, or 13 through 24, or 25 through 36. Another category would be halves. We have the first half and we have the second half of the board. The first half would be the numbers 1 through 18, the second half 19 through 36. We have evens on the board, which would be the numbers 2, 4, 6, 8, 10, etc., all the way through 36. I do want to point out that evens do not include 0 and 00 in the game of roulette. Another category would be colors. Black would include 2, 4, 6, 8, 10, 11, 13, 15, 17, 20. The reason why it's not just 2, 4, 6, 8, 10, 12, etc. is because that would be the same as evens and odds. And the last one you would need to know for the purposes of this class would be columns. And columns would include these here. So this is the first column, this is the second column, and this would be the third column. And again, 0 and 00 are not included in the columns. There are other words that you don't necessarily have to know, but in the future, if you ever were to play, you could also have a split where you place a bet between the numbers 1 and 2. You could also have something called a corner where you place it in the corner and place a bet on the numbers 1, 2, 4, and 5. You could also place a bet on a street, which would just be all the numbers in one of these rows. There are many other categories in the game of roulette, but we are going to focus on the ones that you mainly see on the board. That would include the 3 dozens, the first and the second half, the evens and odds, black, red, as well as the columns. To introduce the word union, what is the most efficient way for a player to place their chips if they wish to cover the entire board? My sample space includes the numbers 0, 00, and 1 through 36. So therefore, my entire sample size would be 38. If I wanted to cover the entire board, then what I would have to do is place a single bet on the numbers 1 through 36. So I place a chip on every single one of these numbers, as well as 0 and 00. Is that a good or a bad strategy? Well, let's pretend that we spin the wheel and the number lands on 15. Thankfully, I do have a chip at 15. However, in order for me to cover the entire board, I had to put 38 down. So I spent, if I put $1 chip on every single one of the numbers, I would have put down $38. If it lands on the number 15, then the payout would be 35 to 1. So then I would have made 35 back since I put a $1 chip there. It's clear to see that in order to cover the entire board, I'm still at a loss. Another way I could have covered the entire board is to put a chip on 0, put a chip on 00, put a chip on first dozen, second dozen, and third dozen. I would have put $5 down on the board, and imagine the number landed on 30. I would have won because I have a chip down on the third dozen. However, I would have gotten a payout of 2 to 1. So if I put $1 down, I would have made $2 off of that chip. Again, I am still at a loss. There is no good strategy in order to cover the entire board. Otherwise, everyone would make money when playing this game. So introducing the word union. The vocabulary term itself may be new, but the concept is not new to us. A union is a set that contains all the elements of their subsets, and it has the symbol U. You've seen this before. The union symbol represents OR. You've seen this symbol before when we learned about inequalities and writing answers in interval notation. For example, if you were to solve a quadratic or absolute value inequality and you ended up with a solution of x values less than -5 or x greater than 2, we stated that all the possible x values would be between -infinity to -5 or, so union, 2 to positive infinity. This union symbol has always represented the word OR. What is the union of the first dozen and the second dozen? The first dozen and the second dozen are both categories of the sample space. The union would be to create a set that contains all of those elements. So they would include all the numbers between 1 through 12, as well as all the numbers between 1 through 24. What is the union of the third dozen and the evens? The even numbers would be 2, 4, 6, 8, 10. Again, in the game of roulette, 0 and 00 are not counted as evens. The third dozen would be the numbers 25 through 36. You'll notice that some of the numbers are circled twice. We don't want to include any of the numbers twice, so I would simply list out all the numbers that we have circled in yellow. That would include the numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then we would list every single number in the third dozen just once. 25, 26, 27, 28, etc. through 36. Exclude any of the overlap that happened. I hope this reminds you of what we were doing last class. We learned the word or as well as and. We said the probability of A or B occurring would be equal to the probability of A plus the probability of B, and we subtracted out the probability of both A and B occurring. We did this when the two events were not mutually exclusive. Instead of using the word or, we now can rewrite this with the symbol union. The probability of A or B occurring would be the probability of A plus the probability of B, minus the probability of both A and B occurring. Our next example, blacks and the first half. Similarly to what we did in the previous example, the first half would include the numbers 1 through 18. In addition to that, any of the black numbers that are remaining, 20, 22, 24, 26, 28, 29, 31, 33, and 35. If you want to shorthand it, you could also write in brackets 1 through 18 for all positive integers, as well as all the remaining black numbers. For the last example, the reds and the second column. All the numbers in the second column would be listed, as well as all the remaining reds, since we are finding the union. This isn't a question that's posed on your sheet of paper. However, what if I were to ask you, what is the probability of the first dozen or the second dozen? The probability of the first dozen would be 12 out of the total 38 different outcomes in my sample space. The second dozen would also be the 12 numbers 13 through 24 out of the total 38. Union, since we are finding the set that contains all the elements, the word or means to add these two probabilities, and that would be equal to 24 out of 38, which you could reduce to 12 out of 19. To introduce the word intersection, if you could cheat and make the ball land on a number like 13, what is the most efficient way for a player to win more than once? If you can guarantee that the number is going to land on 13, there are many different ways you can win. You can put a chip on the second dozen. You can put a chip on black, 1 through 18, the first half, on odd, first column. Lastly, you can put a chip on, of course, the number 13 itself. So you can place a chip on 1, 2, 3, 4, 5, 6, and this isn't the only 6. You could also do a split, etc. But there are many different ways that you can win more than once, and this would be an example of an intersection. An intersection is a set that contains all of the elements that the subsets have in common. This symbol is what looks like a reflection of a union symbol. This symbol here represents an intersection. What is the intersection of the first dozen and the second dozen? If an intersection is a set that contains all of the elements that they have in common, then I would have to find what does the first dozen have in common with the second dozen. In this case, there is no overlap. If there is no overlap, then there is no intersection, and the answer would be none. What is the intersection of the third dozen and the evens? The third dozen would be the numbers 25 through 36. The evens include the numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. The intersection would be what they both have in common. So we don't have to worry about the evens between 2 and 24 because the third dozen and the evens have an intersection of 26, 28, 30, 32, 34, 36. What is the intersection of the blacks and the first half? The first half would be the numbers 1 through 18. Blacks would include the numbers 2, 4, 6, 8, 10, 11, 13, 15, 17, 20, 22, 24, etc. But I don't have to worry about the blacks that are not in the first half since I am looking for the intersection. Lastly, what is the intersection of the reds and the second column? It would be all the reds that are in the second column. The reds in that second column would be 5, 14, 23, and 32. Hopefully at this point you recognize that the intersection symbol represents the word and. Complements. A complement is the set that contains elements that are not in the subset. There are two symbols that you may see. It could either be a bar over the name, such as evens with a bar over it, or written with an apostrophe at the end, evens apostrophe, that also means a complement. So what is the complement of the first dozen and the second dozen? What is not included in the first and the second dozen is the question that we're answering. That would be everything else. 0, 00, as well as the third dozen. What is the complement of the third dozen and the evens? These are all the numbers in the third dozen. It would be all the numbers that are odd in the first and second dozen, including 0 and 00. What is the complement of blacks and the first half? All the reds that are in the second half, as well as 0 and 00. Lastly, what is the complement of the reds and the second column? It would be all the blacks in the first and third column, as well as 0 and 00. So 0, 00, 4, 6, 10, 13, 15, 22, 24, 28, 31, 33. Please go ahead and pause the screen at this time and practice with the new notation. Please go ahead and check your answers at this time. Normally, if we were in class, we would play this game together.